Welcome everybody to today's webinar. Today we're going to be going over the Ziva 1.4 features. So the people that have just joined, it's usually Ashton who starts these meetings. As I said, she's having technical issues, so it's just going to be me by myself. And yeah, so we're going to be going over some of the new features in Ziva 1.4. So in this scene, we've got a person's face, and if you didn't know, this is Ziva's CEO and co-founder, James Jacobs, who's kindly given me permission to use his likeness in the name of science. So what I've done here is I've basically chopped off the head and I've sealed the bottom here. So basically I have a closed volume. So when I converted it to tissue, I got tets all the way through. So it's not just kind of tetrahedralizing the surface, the whole thing is one solid tissue. So what I'm going to do is I'm going to add a turbulence field to this to make it look as if he's kind of moving quickly through space. To do that, really easy workflow. So you just select the tissue object, and then under the Ziva menu, come down to field, and then I can put in, I'm going to choose, these are all just basically the standard Maya fields. So I'm just going to select turbulence. And now if I look in the outliner, should see a turbulence field. So if I just play this back now, you're not going to see much. And the reason for that is Ziva needs quite high values in the fields in order to see results. So I'm just going to keep adding a few zeros until we see something, basically. So let's try that. Need a few more. This will change depending on how stiff your material is. So the other thing I'm going to do is I'm going to animate the phase. So I'm just going to key this to 0, and then on frame 55 I'll make it 10. I'm going to clear the cache. Yeah, so if the material here is, I think these are the default values. So if this was, 10 times weaker or whatever, you'd need lower values in the turbulence field in order to see something, but they need to be kind of quite high. So you can see now, this is solving at 3.8 frames a second. So if I've got a cache in here, so if I scrub through this now, hopefully the frame rate's good enough so you can see the kind of wave propagation going through there, and it looks pretty organic. If I select the mesh, you'll see that the TET mesh is also wobbling around as you would expect. And then, yeah, from here you can add more fields, tweak the fields, obviously. It really is as simple as that to add fields. If I wanted to add another one, if I wanted an air field or whatever, I just have this selected, and then under the Ziva menu, add field, or field here, and then air field, and then you could give it some direction or whatever. Yeah, so that's the workflow for that. If you already had a field, so if you were just using the normal effects menu and field, and I made an air field, if I go into the node editor, there are commands to do this. I think if you do Ziva-H, you'll see there's the commands here, and then fields, connect field here. So with no arguments, it's going to connect everything. It'll connect all field nodes to all selected Ziva bodies. Yeah, or you can pass it specific ones, or you can just go into the node editor. And I believe, so when you make your first field, you get this field adapter node. And then if I get the air field, I can add this. And then, oh, actually, I think you need, every field needs its own field adapter. And then you basically connect the message attribute across. So I think to get message, you need to show the hidden ones from memory. Message, and then connect it to field. And then if you look in here, you'll see that there's, yeah, I've been playing around with the scene before I started the webinar, so I have a couple of empty field array things, but you just connect it to the next available slot, like that, and then you can stack them up that way. That's if you already have a field in there that you wanted to connect. Other than that, use the command. Cool. Cool, so I'm just gonna delete the fields for now because I don't have anything more to say on that. Clear that, clear the cache. The next thing we're going to show is rest scale. So in Ziva 1.3, you remember that we had rest scale and pressure on cloth. Those attributes are now available on tissue in Ziva 1.4. And we've also added a third attribute, which is called surface tension, which I do talk about in a tutorial that I recently posted. And we'll talk about that in a minute. But firstly, I'm just going to show you a use case for rest scale. And so rest scale will, just like the name suggests, scale the tets uniformly. It's going to scale their rest size though. So it's not going to add any extra force into the system. It's just going to change the size of the tetrahedra at rest. So what I'm going to do in this scene is I'm going to try and make James's neck inflate as if it was like kind of a frog neck. So what I'm going to do is create a new material. Under the Ziva menu, you come down to add tissue property material layer with the tissue object selected. And you'll notice you get a second material here. So I'm going to multiply the rest scale by, I'm going to add 50% to it. I'll make it 1.5, like that. And then I'm going to paint its effect. I should probably talk about this scene a little bit more. So this is a solid tissue, and then on the inside we have some objects. So I've got a skull in there, a jaw or a mandible, and then some vertebrae, and then they're just kind of attached to the tissue, just the simple attachment. The eyes are tissue objects, and they're also attached to the tissue volume, that is the skin. Cool. So what I'm going to do is paint this material layer now. First, I'm going to flood it to black because I'm going to want it to be off for most of it. And then if you want to paint stuff faster, you can switch the solver off. So turn its value to, you can turn enable to 0. And now when I paint, it's going to be a lot more interactive. That's a fun tip if you're authoring stuff, you want to get faster feedback. So when I was doing this yesterday, I noticed that because I had James in the office, we could sort of test a little bit of this stuff. And we noticed that the effect goes right up in the cheeks as well. Obviously, you can't really inflate his neck, but doing a cheek puffer, it went all the way up to under the eyelids. So I'm going to paint that, just smooth this off. I'm going to switch the solver back on. And what I'm going to do is on the tissue node, I'm going to key this effect on. So I'm just going to set some keys here quickly. And I'm going to try and make it sort of come in and out kind of quickly and hold for a bit. Oops. So you can see it's kind of doing something here. Yesterday the effect was a lot more. Just trying to think what that might be. One thing I was doing yesterday is I had the attachment on the head, on the skull. I had this a lot weaker, so it was kind of affecting everything a bit more. So I think when I switched the solver back on, it didn't update. I just painted a little bit more with the solver on and it kind of refreshed. But you're getting a pretty cool effect here now. You can see everything's kind of inflating, including the cheeks. And you can do cool things. I'll just hide the skull because that's a bit distracting. But while it's a completely kind of, you're artificially scaling the text, so it's kind of not physical in that respect, but it looks quite natural. You'll notice the paths of the vertices and things are kind of non-linear. The other thing you can do now is combine that effect with surface tension. So if you add surface tension on, it's going to, like the name suggests, put tension at the surface level. So it's going to hopefully create a nicer curve when this stuff inflates, similar to how a raindrop kind of has tension on the surface and keeps it kind of all smooth. So what I'm going to do is use the same animation curve. That is, I'm just going to plug that into surface tension envelope on the tissue. So now if we look at the tissue, see there's 2 keyframes running in there. And I'm going to set surface tension on that same material to 150. So this is, I go over this in the tutorial, the new tutorial on the website. But basically, if you imagine this is the surface triangles, and then these are the normals. Surface tension's only going to add tension on the surface. It's actually going to shrink or grow the triangles depending on what the value is. It's going to put a force on the tetrahedra at the surface in the orthogonal direction to the normal. So, it's only going to be in this direction. You won't get anything in the normal direction. So it's anisotropic or non-uniform in that respect. So that's just a little something on surface tension. And so I think now that should change the shape a little bit. Cache. Yeah, so it's kind of the effect is a bit smoother. Just let that finish caching. With Ziva, you can do a lot of things that are not just strictly anatomical simulations, so this is kind of what I was saying at the start of how it's going to be a bit more of a fun lecture where you can just show that, you can do all kinds of stuff with Ziva with the new features. So you could use this potentially as a modeling tool as well. If you had a character that needed a lot more mass, you could do something like this. Cool, so that's rest scale. From there, I can move on to surface tension. I'll just talk about surface tension a little bit more. So if I got this scene here, so the major effect of having surface tension, pressure, and rest scale on tissue is that now you don't need to run a fascia in your anatomical simulations. So in your character work, if you're running a fascia before, you probably noticed that it was kind of a bit of a bottleneck because the cloth can be a little bit slower than tissue. Yeah, so now with Ziva 1.4, you don't need to effectively run a fascia anymore because you can replicate that functionality directly on the fat. So this simulation was done, this is just a bake, but this was done without a fascia. So the muscles and bones were done in exactly the same way. I didn't use any of the new features at this part, but at the fat level, and again, I've done a whole tutorial on how to do this, so you can check that out on our tutorials part of our website. But basically, as you saw with the face where I was doing material layers, it was a similar thing with this guy. So on the inside of the fat, so basically the surface that's adjacent to all the underlying objects, the muscles and the bones, which was effectively the fascia before. On that part of the surface, I have a material layer that's active, and that has a certain amount of surface tension on it. And surface tension in that instance is going to kind of do a similar thing to what rest scale was doing on the fascia. It's going to shrink down the inside of the fat, and it's going to keep it tight onto the underlying objects as they move through space. And there's also a bit of pressure on that material as well, which will hopefully reveal the valleys between the muscles and the bones. But yeah, go ahead, and I think that's probably too much for the webinar today to go through all that stuff. But yeah, there's a tutorial on that on the website now, so definitely worth checking out. Cool. So the next thing I want to talk about is muscle growth. So what I'm going to do is I'm going to open a scene. Yeah. So this is kind of the standard entry-level demo scene that I often open. So this has just got a bake of, this is the standard kind of range of movement bake that you get if you download Mr. Ink, which for people who don't know is a free asset on the Ziva eStore or free store that you can download, and you can kind of test stuff yourself and kind of inspect the choices we've made, that sort of thing. So I'm going to use this. This is just an alembic bake. I'm going to use this alembic to drive these bones just with a blend shape. So I have a button to create a blend shape between two objects now, because I do this so often. Right, that key. Now, cool. So now these are following. I'm just going to hide this now. I'm going to convert these to Ziva bone objects. Make this a Ziva tissue. I'm just going to hide the brachialis for now. And then I'm going to build some attachments at either end. Like that. Cool. So now the tissue's following around. Muscle growth is a kind of a useful feature where you can arbitrarily grow tissues in the direction or the orthogonal direction of a fiber field. So you have a scene or a shot where the VFX supervisor just wants the bicep bulge to be bigger, right? That seems to come up a lot. Well, you can use muscle growth to achieve that effect. And that's kind of what it's all about. So I'll make a fiber on this guy now, muscle fiber. And then you'll notice on the fiber now that there are 3 new attributes. So if you want to use it, first you have to turn it on. And then you have to define how much growth scale you want. So I'm going to make this 1.5. And then that's going to instantly bring it on. So the growth scale is keyable, or you can use line of action to drive it. So I'm going to do that just quickly, just to show you how that works. I'm going to use the Ziva Tools menu to help me make the line of action curve. And I'm kind of going through this quite quickly. And there are tutorials on doing this stuff, on what line of action is and everything. So if this is all kind of a bit new to you, you'll be able to go back and look at those tutorials. I'll just pull out this end to make things a bit more obvious. And rivet the stuff together. Cool. And then I'm going to connect the line of action, connect the curve to the fiber using muscle line of action. So with the curve selected and then the tissue object, come down to add muscle line of action, select the curve. You can see one of its outputs is line of action now. Cool, so that's all fine. And then, so you should see the muscle. I'll just turn the muscle growth off for now. And so, yeah, you can see when the arm bends or when that curve gets shorter, this muscle's firing. So you can see it bulging a little bit, and you also get the tension in the muscle changes, which is good. And so now I'm going to go back to the fiber, turn that back on, and then I'm going to activate use LOA or line of action for muscle growth. So it's only going to grow when the the curve gets shorter, hopefully. So clear that. Oh, there wasn't actually a cache. Might add one. So you can see now that it's over cranking the bulge. So it's a pretty cool tool to be able to get fast kind of results without having to go through and manually sculpt a shape that you want to hit. So we had we see it quite often where studios modeled or they've created a character that's quite skinny, and there's just a couple of shots where you really want to see the muscle bulge, or he's doing some kind of pose where it's just important to, you know, really make him look quite ripped. And this is kind of a nice way of doing that. Could also potentially be used as a modeling tool. So if you needed kind of a bulkier version of your character, you could, you know, you could have a scene where you just have your character with no animation on it, and then you ramp on your muscle growth over a few frames, say 10 or 20 frames, and then you run your VAT sim on top of that, and then that could then get propagated to the final skin. So it might be a nice way of kind of getting a head start on modeling a character that's a bit more bulky. So that's muscle growth. Just to add one more thing to that, you can add more than one muscle fiber as well, and kind of get sort of a bit more technical with doing this stuff. So what you can do, say for instance, say you just want to have one part of the muscle bulge, you can paint the fiber weights. So say I wanted to just have it bulge on one side like this. This is all completely supported. That. And maybe you wanted to do the other side as well. Then you can just add another fiber. So now I have two, and I can paint the weights for that one as well. And then when you have two fibers connected to your tissue and you want to connect line of action to it, you have to be specific about which ones you have selected. So you need to have the curve selected, and then instead of selecting the tissue as you would normally, you have to add the specific fiber to your selection. So I'm just going to use Mel to do that. Select add Z-fiber 2. And then when I make a muscle line of action, it knows how to build it. And then I'm going to turn muscle growth on with 5. Use line of action for muscle growth. And then you might see some interesting-ish effects by doing it like this. So it's just going to bulge on either side like that. Yeah, so I just thought I'd show that stuff as well. Now the last thing I have on my list is the new scene UI stuff. So this is built on top of ZBuilder, so you'd need to have ZBuilder installed, which I think happens by default now when you install Ziva stuff using the module. So in the Ziva menu, if you launch UI, right, so there's a bug in it at the moment. If you have objects with the same name, it won't launch the UI. That's a known bug. I'll just call these driver. Cool, try that again. Right, cool. So when you launch this, you get kind of a nice way to map out your Ziva scene or your Ziva data. For instance, it can be kind of a bit of a pain to select a line of action curve on a muscle. So if you have your tissue selected, you can come down to, you can see all the Ziva stuff that's connected to it. You get some nice little icons. And then you have the fiber here, which you can open. And then you have the Z line of action node. And then from there, you can right click on this, I believe, and you can select the curve that's associated with that node. So that's kind of a nice feature. It's just nice to be able to kind of scrub attachments as well, because that can be a bit of a pain trying to find the right attachment. Because yeah, in Maya 2018, they changed the API, or they changed the way that you interact with the viewport. It's not really possible to make GL things selectable in the viewport anymore. So that functionality went away, which was a bit of a shame. So this is kind of a nice way to to scrub through and get things back using that. So if you click and drag, it'll just quickly select stuff, which is pretty sweet. It's not a two-way thing. So if I select something else, it's not automatically going to update in the viewport. You do need to hit this little refresh button when you select something else, and it will change what you're looking at. So that's kind of a new addition. But yeah, I think that is it for the Ziva 1.4 stuff. I don't know if there's any questions on that.
Hey Andy, how's it going?
Hey, good. I can hear you.
Hey, sorry everybody. I was a bit late coming today. We're at XDS, which is the External Development Summit. And so we are in the middle of a conference right now, but I figured I could catch at least part of the webinar today. Sorry, I missed the last little bit there.
I kind of finished up on the 1.4 stuff, and I was just going to go through a few questions.
Yeah, Jason was wondering why we have gravity turned to 0 and on Mr. A.
Oh yeah. If it's not, I mean, it probably should be. If it's not, yeah, you definitely want to have gravity in your fat simulations, because otherwise it won't look right. So if I forgot to do that, then that's probably my fault. You won't turn gravity on when you're doing the modeling side of it. So if you're modeling the inside of the fat, then yeah, you want to turn that stuff off. That's probably what happened if it's off.
And a follow-up to that, Jason was wondering if you're wanting to add weight to the fat tissue in different areas, what would you recommend?
Yeah, you'd use layered materials. So there's a tutorial on layering materials. I did it for if you wanted to have varying materials. Say if you had armored plates on a skin, so if it moves a rhino or something like that, and you wanted the plates to sort of maintain their shape, you can just stack up materials and paint them. So yeah, but that would be the same thing. The thing you would change is density. So if you want to see more secondary effect, you would paint a material and change its density so it's more dense than the surrounding material.
Awesome. I just gave the link to that tutorial in the chat, so you guys can check that out. The next question came from Chris. He says, I have one general question regarding the solver cache. Do we have an option to cache on the file on disk rather than using RAM? He's noticed that when there's a large number of frames, the Ziva file crashes at say 1,000.
That's because our caching is not a shot tool. It was kind of designed to be an authoring tool. You could just interactively test things and then scrub the timeline back to preview the results of your test. The caching is, you can save things to disk. So if you want to do that, I would suggest changing your pipeline so that if you look in the, I think if you look in the Mel editor, sometimes my script editor takes a while to open. Okay. You do zcache -h. You notice there's a whole bunch of commands for it. So what I suggest you do is, as you're caching your simulation, you save the Zcache on every frame, and you only save it for that frame, and then delete the cache. So delete the cache in the scene, I mean, or clear it. So that way everything goes onto disk, and you don't overshoot your RAM allowance for the simulation. And then that way as well, you can kind of go back, you save the scene, and you can go back to any frame of the simulation and kind of start from there if you want us to do that. So
T. Roberts had a quick question. He missed the first part of the meeting. That head was cool. What was it? That was James Jacobs. That was the co-CEO and founder of Ziva, and we just got a scan of his head and then made amazing things happen to it. He says, James is amazing. I agree. Wow. Andy's getting jealous. We better stop.
Yeah. He's running this lecture. Yeah, okay.
And yeah, thank you so much, everybody, for hanging with us and coming to, I don't know, what is it, our 5th or 6th Live with Ziva now? They've been a huge success. We're really happy to see the community growing. Awesome.
Cool. Thank you, everyone, for signing in, depending on where you are in the world. I know it's tricky for some time zones and things like that, so it's great to have this kind of engagement. So yeah, thanks very much from me.
Bye.
Cheers, bye.